An Introduction to Logarithms. Part 2. How to write them. Mathematics is a language like any other. It has an alphabet, a vocabulary, and grammar. In the previous video, you learned that any number, a, may be expressed as 10 to a logarithm. With your calculator, you learned that the logarithm function finds the value of a logarithm, and that entering the antilogarithm function, 10 to the L, finds the value of antilogarithm a. How to write a logarithm function. When we are given the value of a number, which we shall call a, and are looking for the value of its logarithm, which we shall call L, we may write the equation for the logarithmic function in the most general way as L equals f of a. But there are special forms and terminology for logarithms. The function statement is abbreviated log. The number a for which we seek a logarithm is called the antilogarithm. The base, b, is indicated as a subscript. Our base is 10, though it could be something else. Stating the equation in plain language, for both ways of writing it, we have L is the exponent of 10, that produces a, and the exponent of 10, that produces a, is L. Here are two more examples. The log of 100 is 2. The exponent of 10 that produces 100 is 2. The log of 342 is 2.5340. The exponent of 10 that produces 342 is 2.5340. A equals b to the L, expressed as a general function, is a equals the f of L equals b to the L. But, using logarithmic vocabulary, we use the antilogarithmic function, and it is written a equals the antilog, base b, of L, equals b to the L. The antilogarithm function, being an exponential function, means raising a base to a variable power. A is the antilog value. Antilog is the function statement. Subscript b is the base, which is often 10. L, the argument, is the value of the logarithm. B to the L is the function formula. It reads, the antilog of L, base b, is b to the L. One last bit of notation to learn. The antilog function may be abbreviated as log, superscript -1. This is so because the log and antilog functions undo one another, meaning they are inverse, and because the superscript, -1, is often used to indicate this fact. The subject of inverses in logarithms is covered in a later video in this playlist. Let's compare some functional notation. Let b equal 10. The standard form is y equals f of x. The log form is L equals log, base 10, of a. And the antilog form is a equals antilog, base 10, of L, which equals 10 to the L. You may be looking at these two formulas and wondering about the lack of symmetry. Why isn't there a simple formula that we can plug in here? Recall that I previously mentioned that mathematicians spent years working these values out. Here is the Brave Browser AI explanation of the process. So, in fact, there is no simple formula for a logarithm. The logarithm values developed by John Napier, and those who continued his project after his death, were put into tables. These table values are programmed into calculators. Always be aware that the words logarithm and antilogarithm may refer either to a value or a function. Context is important. Two additional points. When working in base 10, it is not always necessary to write the subscript 10 after the word log, because log frequently means, specifically, base 10. To speed up the writing of logs, we may occasionally omit the parentheses around the argument, as in log 342. In the next video, you will be shown how to use logarithms to multiply and divide.